All right, hi folks, this is Larry Mussolino. I wanted to record a video to help out with the Module 2 homework. This is on Chapter 3. I want to show you how to use StatCrunch to help with a few of these homework problems and also how to do some of the other examples as well. All right, so let me start here with question 1. This one says the marketing team at an internet music site wants a better understanding of who their customers are. They sent out a survey to 25 customers, and they wanted to record customer ages. So this table are the 25 customer ages. All right, let me go to part A. Part A says, make a histogram of the data using a bar width of 10 years. So what that means is each one of these bars should span 10 years. Well, it looks like the horizontal axis is going from 0 to 50. So if each bar is going to span 10 years, I should be expecting 5 vertical bars. All right, well, I can either use Excel or StatCrunch to set up this histogram. I'm going to use StatCrunch. So I'm going to come here and click on this copy icon here. And I'm going to open the data set up in StatCrunch. And that didn't work, so let me try it again. All right, there we go. And so the data is copied here into this first column. It's called var1, but I could change this column name if I want to be more descriptive. All I have to do is click my mouse here, and I'm going to change it to the ages because that's what these numbers represent. I don't have to do that, but it's just a little more descriptive. All right, so I want to generate a histogram. Well, anytime you want to generate a graph in StatCrunch, you go to this graph menu. So if I click on this graph menu, you're going to notice there's many graphs available, one of which is a histogram. So I'm going to pick histogram. And now what StatCrunch needs to know is what column do you want to create the histogram from? Well, I call the column ages, so I'm going to click my mouse right here where it says ages. And when I do that, it copies the column name over here to the right to tell me it's selected. All right, well, if you notice, there's a couple of options here. It says, where should you start the bins at and what should be the width? Well, I'm noticing that our graphs are starting to get 0. So I'm going to put start at 0 here. And the problem said use a bin width of 10. Right here it said use a bin width of 10. So I'm going to make this a 10. And that's all I need. I'm going to click compute. And so here is my graph. And now I can compare this to the choices in my math lab. Let me move this over a little bit to make it easier to, let me see if I can get this side by side. All right. So it looks like this first bar here is at a 0. Then I have a 2, then a 7, then a 10, and then a 6 here. I'm just looking at the heights of each bars. Well, it looks like the only graph that matches up is this one right here, because here's a 0, here's a 2, here's a 7, here's a 10, and there's a 6. So this must be the correct graph. All right, let me go to part B. It says do the same thing, but now make the width 5 years. And it did tell us use 0 for the lower boundary. So we did do that. Well, let me go back to StatCrunch, and here's a little shortcut. I can just click up here in the options and say edit. That takes me back to the original menu. And now the only thing I'm going to change is the width. Instead of being 10, this part of the question asked me to make it 5, so I'm going to make it 5. All right, and here is my new histogram. Let me go and compare this to the answer choices. Well, if I do a close comparison, notice there's 2 zeros, right? This interval is a 0. This interval is a 0. Then there's a 2. Then there's another 0 here. Well, the only graph that seems to match that is this graph right here. So it's this answer D. All right, let me go to part C. Part C says, make a relative frequency histogram using a bar width of 5 years. Well, it turns out a relative frequency histogram is exactly the same shape as part B. The only thing that changes is the vertical scale. So when you create a relative frequency histogram, it's exactly the same shape as the frequency histogram. So what that means is for part C of this problem, I'm looking for the exact same shape, the exact same graph from part B. Well, this was the answer for part B. And that graph is basically reproduced here. The only thing that's different is the vertical scale. So this must be the correct answer for part C. All right, so creating a histogram in StatCrunch is straightforward. You go here to graph, histogram. You could tell StatCrunch where you want the bins to start and what the width of each bin should be. You could get fancier. You could put an x-axis label, a y-axis label, title, and things like that, but we don't have to do that if it's not necessary for these MyMathLab questions. All right, so that's question number 1. Let me go on and do another example. All right, let me come here to number 3. So again, this is kind of a similar setup. We recorded the ages of 25 customers. And this one, they're already giving us the histogram. So they're showing us what this histogram looks like over here. And if you notice, this histogram is symmetric. What that means is the left side of the graph is basically a mirror image of the right side of the graph. So this is sometimes called bell-shaped. Later on, we're going to discuss this as normal distribution. Okay, and we also call it symmetric. So these are all ways to describe that graph. All right, let's go to the first one. It says, would you expect the mean to be smaller, bigger, about the same as the median? Well, it turns out that when you have a graph that's symmetric, the mean and the median are about the same. So the mean and the median are approximately the same. Well, they're going to ask us to find the mean and find the median. Now, notice here they say about the same size. We don't mean exactly the same. We just mean approximately the same. Well, to find the mean and the median, I'm going to let StatCrunch do the work. So I'm going to open this data set up in StatCrunch. And if I want to get different statistical measurements, one easy way to do that is go to Stat Summary Stats. Stat Summary Stats is a way to get various statistical measurements on a column of data. So I'm going to go Stat Summary Stats columns. I'm going to select this var1. That's the column name I'm interested in. And I'm going to select from this menu mean and median. I could select more, but this question is only asking me for mean and median. So I just selected them. Here they are on the right-hand side, telling me I did select them. I'm going to click compute. And it looks like the mean is 31.24 and the median is 33. So here are my answers for this question. Again, these two numbers are approximately the same, which is true of a symmetric distribution like this. All right, folks, let me look at another question here. This one's number 6. Again, we have a survey of 25 customers with their ages, and it says standardize the minimum and maximum ages using a mean of 32.8 and a standard deviation of 9.504. And I could see they're really asking me for what's called a z-score. Well, a z-score is a way to standardize a measurement using the mean and standard deviation of the data set. First, let's find the max and the min for this data set. So I'm going to open this data set up in StatCrunch. And I'm going to go to Stat Summary Stats, Stats Summary Stats columns. And I'm going to select the column called var1, and I'm going to get the min and the max from this menu. So this is just a quick way to get the min and the max. I could have figured it out myself by just scanning the data, but I let StatCrunch do it for me. So it looks like the min is 12 and the max is 47. All right, so now that we have that, let's go back to this question that asks us to find the z-score. Well, to find a z-score, the formula looks like this. If you want a z-score, you take the measurement, subtract the mean, and divide by the standard deviation. So this is a formula to use anytime you want a z-score. So let's do it for the min. Well, the measurement for the min is 12. So let's calculate the z-score. So this is going to be 12 minus the mean, that's 32.8, that was given to us, divided by the standard deviation, that was given to us as 9.504. And if you work this out on your calculator, it gives us negative 2.113. What this is telling us is this minimum, 12, is 2 standard deviations below the mean. So a z-score is really telling you how far the measurement is from the mean relative to the number of standard deviations. Let's do the same thing for the max. The max is 47. So for that z-score calculation, I'm going to take the measurement 47, subtract the mean 32.08, divide by the standard deviation, work this out on my calculator, I'm getting 1.570. So that means the max of 47 is about 1.57 standard deviations above the mean. Which has the more extreme z-score, the min or the max? Well, the min is more than 2 standard deviations away. The max is only 1.57 standard deviations away from the mean. So the min is more extreme in that this is over 2 standard deviations away from the mean. So the min here is more extreme. How old would someone with a z-score of 3 be? Well, for this one, they're giving us the z-score. So the z-score is given to us as 3. The measurement is unknown. I'll just call that measure. I'll call it measurement. Minus the mean, that's 32.08, divided by the standard deviation, that's 9.504. I'll just solve this equation for the measurement, and if you do that, the measurement turns out to be 60.592. The way I would get started to solve this equation, by the way, is I would multiply both sides by 9.504. Because if I do that on the right side, the 9.504 on top would cancel out with the 9.504 on the bottom. Then I could just add 32.08 to both sides of the equation. That would let me solve for the measurement. All right, so for this, we needed to know this z-score formula. By the way, folks, remember, you can use these help buttons. There's a view an example button here. There's a help me solve this button, right? So please use those help buttons anytime you need some extra help. All right, folks, let me come here to question 9. And this one says, send out a survey to 25 customers again. And now they recorded the age and gender of the customer. Then it says, construct box plots to compare the ages of men and women. So what they want is a side-by-side box plot where the left side is males and the right side is females. So this is a box plot for the age of males. This is a box plot for the age of females. All right, I want to let StatCrunch help me out here. So I'm going to open up this data set in StatCrunch to begin with. Okay, here it is. And I want to go to graphs and I'm going to select box plot. Here it is. And I want to really plot the ages but I know I want to separate it by the gender. So I'm going to select the column called age. And if I come here, group by, this allows me to separate the data and group it. In our case, we want to group it by sex or gender. All right, and then I'm just going to click compute. And here are the side-by-side plots. Now, it turns out StatCrunch plotted females on the left and males on the right. So I got to be careful because, you know, my math lab is plotting it with males on the left, but that's okay. I can easily compare. Let me see, maybe I can move this over here. And let's try to compare these two graphs. So it looks like when I do this comparison, I know the males, the box plot for males is below the box plot for females, right? Well, that means this graph is wrong because the box plot for males is above. This graph is wrong. Again, the box plot for males is above, so that's no good. So let me come over to choice C or D, and let me try to compare choice C and D here to see, can I identify any differences between these two plots? Well, one thing I'm noticing is they're showing these outlier indicators here. But our graph doesn't have any outlier indicators. So that looks like graph C is incorrect. So it's going to be graph D. And it says the ages of female customers are generally higher than male customers. Yeah, that makes sense because I can see the box plot for females is sitting higher than the box plot for males. All right, so I was able to use StatCrunch here. Again, I went to graph box plots for this. And just a reminder, anytime you want a graph, go here to graph and select from these menus. That's all we need to do to generate a graph in StatCrunch. All right, let me do one more. Let's go to number 10. All right, so number 10 says we have the ages of 100 people for a survey. And here's the minimum age was 11. The maximum age was 297. Something doesn't sound right about that. And they say, are there any outliers in this data? Well, here's how you find outliers. First, you find the lower limit for an outlier. What I want to do is I want to set up an interval here for the expected range of the data. And this number here is going to be the lower limit for outliers. This is going to be the upper limit for outliers. If I have any data values above the upper limit, I'm going to flag these as outliers. If I have any data values below the lower limit, I'm going to flag those as outliers. So how do you find the lower limit? Well, the formula is you take Q1 minus 1.5 times the IQR. Now, the IQR is called the interquartile range, and you calculate it as Q3 minus Q1. Well, in our example, Q3 is 48, Q1 is 23. So when I subtract these numbers, I'm getting 25 for the IQR. All right, so let's plug in that here. For the lower limit, we need Q1, that's 23, minus 1.5 times 25, which is the IQR. All right, so I'm just going to work this out on my calculator. 1.5 times 25 is 37.5. So it looks like this is going to be a negative number, negative 14.5. That's the lower limit for outliers. And of course, I don't have any numbers below negative 14.5. Of course, I can't have any ages that are negative. So I don't have any outliers on the lower side. Let me do the upper limit for outliers now. Well, the upper limit is Q3 plus 1.5 times the IQ. All right, our Q3 number is 48 plus 1.5 times 25. I'm going to work this out on my calculator. And I'm coming up with 85.5. So this upper limit is 85.5. If I have a data value above 85.5, I'm going to flag it as an outlier. And so notice here it says the upper limit is 85.5. That's what we just calculated. The lower limit for outliers is negative 14.5. We just calculated that. The maximum value of 297. 297 is way above 85.5. Not only that, 297 is impossible for an age of someone, right? So that doesn't make any sense. That might have been a typo or some kind of error in data entry. So the maximum is an outlier. It's also impossible. So what might your next steps be? Well, because there's an outlier that's an impossible value, that outlier should be set aside in the data reanalyzed, meaning remove 297 from the data set. It's impossible. Remove it and recalculate all of these statistical measurements. All right, folks, hope that's helpful to get you started in the Chapter 3 homework.